There was homework and a test due last night. Exam 1 was on Canvas and it should have been completed. I'm going to work on grading it as soon as possible. And hopefully I can talk to you about it after we finish notes on Thursday. And I will also try to do a grade update for all of your homework. And if you've missed any quizzes, I can just get everything recorded and you can know what your grade is right now. That way we can make any assignments up that would help your grade improve if you need to. Okay, notes for homework 5, which homework 5 is due on Tuesday next week. Okay, homework 5 is all about exponents. And exponents represent repeated multiplication. Ten to the fourth. Your base is 10 and your exponent or power is 4. It's asking you to multiply 10 with itself 4 times. Yeah. 10,000. All right, next one will be 1/3 cubed. And let's try to the 4th. We'll figure it out. Okay. Multiply 1/3 with itself. Maybe even higher. Let's go 5 times. We're multiplying 1/3 with itself 5 times. What I'm going to do is multiply across the numerators. 1 times 1 times 1 times 1 times 1 is 1. And I'm just going to write this as 3 with the power of, let's see, 3 multiplied with itself, 1, 2, 3, 4, 5 times. So it's 3 to the 5th. And we'll leave it like that just for now. The first rule we have is called, oh, let's see. Question. Yes, so I have a question. I'll write that down, but also just to be sure I remember, please write an email to me or like a message in XYZ. But let me just write it down. Also, anyone at any time can ask questions. Please feel free to let me know what's going on. Okay, so I'll take care of that request after class. I think what we had is our first rule. It's a rule called the product property for exponents. Yep. Okay. We have a real number A. So I'm going to put it in quotes just so it kind of stands out. Let lowercase a be a real number. Let x and y be integers. Okay, then the rule is to have a to the x multiplied with a to the y. It's a lowercase a with an exponent of x multiply with lowercase a has a power y. Okay, when you multiply two numbers with the same base, you can add their exponents. A base a with the power of x plus y. So this one you might want to memorize. And I'm going to put all of those kinds of rules in a square so they stand out. Okay, I have a few examples. The first one, it doesn't require this property. It just works with some negative signs. If you have -4 squared, multiply -4 with -4 and get +16. This time it's a -4 squared, no parentheses. So the power is on 4 and not on the negative sign. So you would copy this negative down, then take 4 and multiply it with itself 2 times. So this time we have -16. Let's multiply 3 to the 5th. With 3 squared. Base 3, power of 5 plus 2. It's 3 to the 7th. Next one is 5 to the 4th times 5 cubed times 5. We have the same base of 5. And when you multiply numbers with the same base, you will add the exponents. So we have 4 plus 3 plus 1. So I have 5 to the power of 8. Okay, this time we're going to take 1/2 x to the 8th. Multiply it with 10x to the 10th. We will multiply those numbers together and then multiply those x values together and use that rule with the base of x. Okay, first let's just rewrite this. 1/2 times 10. One half times 10 is 5. X with the power of 8 plus 10. X to the 18th. The next rule is called a power property for exponents, or the power property of exponents. Oh no, hi. Sad cat. Okay, so we're going to let A be a real number. I'll be back, you guys. One moment. Let's find a cat toy. Okay, let's try this. Let A be a real number. Let X and Y be integers. Then the rule is A to the power X to the power Y is A to a power of X times Y. So a power raised to a power is the base with the two powers multiplied together. Okay, let's start with something like A to a power of 5 to a power of 3. Base is A, the power is 5 times 3. A to the 15th. Let's do 2 to the 4th, and then with the power of 6. The base is 2, and the power is 4 times 6. It's 2 with the power of 24. Next we have y times y squared. And the whole thing is cubed. So we're going to work inside parentheses and do that first rule. Y to the first times y squared is y to a power of 1 plus 2. So what we have now is y cubed and then raised to another power of 3. You have a power with another power above it, you multiply them together. So we have y to the 9th. The next one is called a distributive property, or the distributive property of exponents. This time A and B are real numbers. And x is an integer. Then a times b with the power of x is a to the x times b to the x. Our first example is to take 3x and have it squared. So we have 3 squared and x squared. Nine x squared. We have 2x, 2 times x times y to the 5th. And all of that has a power of 4. So we'll have 2 to the 4th, x to the 4th, y to the 5th also has a power of 4. So I'm just going to, it's a small enough power that I will expand that number, and then we'll have that rule with y to a power of 5 times 4. Times 4. We've got 16. X to the 4th. Y to the 20th. Now we have excuse me. Let's see. How about go with 5x times 2x cubed and cubed. So I want to work on this piece first. We're going to cube 2 and we're going to cube x cubed. Okay. Two cubed is 8. So far it's 5 times x times 8 times x to the power of 3 times 3. So we can, let's see. Multiplication is commutative, so we could rearrange this here with 5 times 8 times x with the power of 9. So we've got 40, and this base x has a power of 1 plus 9. So this is 40x to the 10th. There's another part to this property. So it's, for real numbers A and B. Oop, also. And an integer R. A divided by B to a power R is A to the R over B to the R. So you're going to apply the power to the numerator, and also this R is a power on the value in the denominator. First one is x over y with power 7. So x has power 7 and y has a power of 7. This time, it's a over b squared, and it has power 4. So take a to a power of 4, and b squared has a power of 4. So a to the 4th over b to a power of 2 times 4. A to the 4th over b to the 8th. Another example, it's going to have in parentheses is negative 3 over x. And it's a power of 4. So what you could do is consider this as negative 3, or you can take the negative. You could take this negative sign, a negative 1, and then you could separate it sort of from 3, which is what I usually do to find out if this number is negative or positive. Take the negative sign, raise it to the power. If it's an even power, it's going to be positive 1. When there's a negative power, it stays as negative 1. This also has power 4. Same with the x down here, has power 4. Okay, since the power on this negative 1 is even, it's positive 1 times 3 to the 4th over x to the 4th. And 3 to the 4th is 81. The next rule is the negative exponent property. let a be a real number and let r be a positive integer. Then a with the power of negative r is 1 over a to the r. So most of your problems, like your homework problems and exam problems, ask that you write your value without negative exponents. So to do that, you need to take this number, push it past the fraction bar, and then you get that positive exponent. Or the other way around, if you want to, like, let's put this as a side note also. If you have 1 over a to the negative r, you can bring it up into the numerator and it changes it from that negative exponent to a positive exponent. So the idea is that here you have your number, which we could always put over 1. And then you push this value past that fraction bar and it has a positive exponent. Or if it's down in the denominator with a negative exponent, bring it into the numerator and it will have a positive exponent after that. Okay, the first example is to write x to the negative 5th without negative exponents. So you can kind of skip this step if you want to, but I want to take x to the negative 5th and put it over 1. I'm going to bring that number down into the denominator as x to a positive 5 and 1 in the numerator as a placeholder. This time we want to write x to the negative 3rd over y with a negative 4 without negative exponents. So bring this up into the numerator as y to the 4th. And then bring this to the denominator, it's x to the 3rd. We're going to use negative 3 the power of -1 over b squared. And write it without negative exponents. So you still have that negative number. It's negative. And we're going to bring b down to the denominator, but leave 3 here. So again, 3 stays right where it is. It doesn't have any negative exponents on it. It's b that we're going to bring down, b to the first, and it's multiplied with b squared. Okay, so don't forget your negative sign. We've got a -3 over b to the power of 1 plus 2. It's -3 over b cubed. We're going to use 2x with a -3rd power. So 2 is just 2. It doesn't have any power on it. It's the x that has a negative power. So 2 stays where it is, and x will come down into the denominator with a positive power of 3. This time we're going to take 2x, the quantity, and then have a negative power of 3. So we can bring this to the denominator. As 1 over the quantity 2x cubed. And then we're going to have 2 cubed and x cubed. Two cubed is 8. So this is 1 over 8x cubed. One more. It's 4 with b to a -1 times a. Divided by b squared, a to the -5th. And the goal is to simplify your answer and write without negative exponents. First thing I want to do is just take care of the negative exponents. 4 sits where it is. There's nothing going on with 4. b with -1, I want to bring down to the denominator, power 1. And a is going to stay where it is in the numerator. This b squared is going to stay in the denominator, and a to the -5th will push up to the numerator as a to a power of +5. 4 times a to a power of 1 plus 5. Over b with a power of 1 plus 2. 4a to the 6 over b cubed. Then we're going to talk about the quotient property of exponents. Let a be a real number. Let r and s be integers. And just put quotes there so that the letter stands out. It's easier to read, I think, if there's a little space. Anyway, when you have a to the r divided by a to the s, you use the same base of a, and the power is r minus s. And since you don't want to divide by 0, we're going to note that a does not equal 0. First one is to take x to the 15th and divide by x to the 10th. We have x to the power of 15 minus 10, which is x to the 5th. Okay, next is 2 to the 18th over 2 to the 20th. The base is 2. The exponent is 18 minus 20. Okay, keep working on this to get 18 minus 20 as negative 2, so 2 to a power of negative 2. It will be clear in each question that you don't want to have an answer with negative exponents. So take care of that part by bringing this value down to the denominator And now your power can be positive too. So this is 1/4. Okay, I think that there are 2 definitions that we need to do, and then that's it as far as like rules and definitions for exponents. And then we'll do more examples, of course. Okay, the 2 definitions. Let A be a real number. And the first one is to take A to a power of 1. It will equal A. And just to note that A does not equal 0. So it doesn't work for 0. If you have A to a power of 0, it is equal to 1. Let's do easy ones, like 5 to a power of 1 is going to equal 5. And let's do 5 to a power of 0. It's 1. Okay, this time we have 7xy squared. Power 1 is going to be 7xy squared. We're going to go with 2a to the 3rd and b to the 5th. All that has a power of 0. Anything with a power of 0 is going to equal 1. Cool. Oh, I know. We're going to do one more like this. Let's do, I picked 7 to a power of 0, add 7 with a power of 1, and then 7 squared. Add to the end. Okay, first piece. would be 1. Any number with power 0 is 1. 7 with a power of 1 is 7. And 7 squared is 7 times 7. So we've got 49 at the end. It's 57 total. And I have another problem kind of like this. We're going to try adding 2 with power negative 1 to 3 with power negative 1. Okay, we're taking care of the negative exponent by putting this value down into the denominator as 1 over 2 with power 1. Same thing here. Bring this down into a denominator as 1 over 3, and its power is positive 1. Which we know is 1/2 plus 1/3. That rule right here. Any number to the power 1 is the same number. Okay, you need a common denominator. So we can multiply 1/2 by 3 over 3. We'll multiply 1/3 by 2 over 2. And our common denominator will be 6. Three sixths plus 2/6 is 5/6. All right, so the rest of the notes are just examples for your homework. All right, for your homework, there are problems like this where it says consider something like capital R squared. What is the base and what is the exponent? The base is capital R and the exponent is 2. This time we're going to simplify. It's x plus 7 to the 12th over x plus 7 to the 5th. We're going to use a base of x plus 7 and a power of 12 minus 5. And that's our answer. We're not going to expand or anything. And leave your answer like that. The next problem is to take x to the 6th times x to the 5th times x to the 10th and simplify. You have the same base x, and we're going to add all the powers together. X to a power of 21. This time we have x to the 6th to the 10th. When you have that base with the power raised to another power, you multiply the powers together. So this time it's x to a power of 6 times 10. X to a power of 60. Cool. This time we simplify. X to the 5th multiplied with x squared times y cubed. And that has the power of -2. So we're going to take care of that negative exponent first and bring this value, x squared y cubed, down to the denominator and change the power to positive. And also make sure that this other value stays where it is. It stays in the numerator. So we've got that down and its power is +2. So this is still x to the 5th. And we're going to square x squared and we're going to square y cubed. So distribute that power. And when it's a power to a power, you multiply. So it's x to the 5th over x to the 4th. And this is y to the 6th. And I just realized that we want one value of x. So we're going to keep working and have x with a power of 5 minus 4. That's in the numerator. It's over y to the 6th. So x with power 1 over y to the 6th is x over y to the 6th. The next one is to simplify. Okay, I see it now. It's 4ab squared, like this. It has a power of 3. It's multiplied with 4ab squared. And that has a power of -1. So what I'm going to do, especially since I've kind of, after reading it out loud, I'm going to take a base of 4ab squared. And this will be our last example for today. I have a lot more examples that we can go over next time. Okay, so this is one way you can solve the problem. Use this base and a power of 3 plus -1. So it's 4ab squared squared. And then we're going to distribute that power on 4, on a, and on b squared. 4 squared, a squared, b to the 4th. B to the 2 times 2. So we've got 16 a squared b to the 4th. Okay, so that's about it for today. On Thursday, we'll finish more examples, and I'd like to go over the test questions, especially like if there's a question that stands out as most missed or something like that. All right, have a good day, everybody. Thank you for coming to the meeting. I'll have it posted